The universe is vast, unpredictable, and constantly surprising us. Our solar system is not an isolated bubble. It is more like a busy crossroads where fragments of ancient stars, stray rocks, and the occasional comet pass through on their way to somewhere else. From time to time, objects appear that challenge not just our instruments, but our assumptions about how space should work. In recent years, interest has grown around these mysterious visitors, especially after the detection of the interstellar object known as Homelin 2017 and Comet Borisov in 2019. Both objects came from outside our solar system, and both left more questions than answers. Now, a new interstellar object, provisionally called 3I/Atlas, is stirring a fresh debate within the scientific community and beyond. The story begins with NASA's ongoing efforts to monitor near-Earth objects, often referred to as NEOs. These are asteroids and comets whose orbits bring them close to our planet. Agencies like NASA track them not only for scientific research, but also because of the very real possibility that one day a large object might collide with Earth. Congressional hearings in the United States have frequently touched on this subject. At one such event, officials highlighted how better detection systems and improved tracking capabilities are vital for planetary defense. The topic might sound like science fiction, but it is grounded in real risk management. Our planet has been struck before, and it will almost certainly be struck again. Against this backdrop of routine vigilance, astronomers first noticed a faint object in July 2025. At first glance, it looked like a fairly ordinary comet. Small specks of light on telescopes are often just that, unremarkable familiar cosmic debris. But over the course of weeks, it became clear that this object was anything but ordinary. The way it brightened, the way it moved, and even its chemical signature began to raise eyebrows. Unlike regular comets, which follow patterns that scientists understand quite well, this new visitor seemed to operate outside the rulebook. That is when it was catalogued as the third interstellar object discovered passing through our solar system, hence the designation 3Is. From a scientific perspective, what makes 3I/Atlas remarkable is not just its interstellar origin, but how it behaves. Normally, comets begin to show activity such as developing a coma or tail only when they move relatively close to the sun. This is because solar heat causes the icy material inside them to vaporize, releasing gas and dust. However, 3I/Atlas began displaying this behavior unusually far out, near Jupiter's orbit, well before a typical comet would have become active. This raised an early flag for scientists observing it. The activity suggested something about the object's composition or internal structure was not behaving like a standard comet. As it approached closer to the sun, the object's brightness surged far more dramatically than models predicted. Astronomers usually calculate the expected light curve of comets, which is a measure of how their brightness should change with distance from the sun. In this case, those calculations were thrown off. Around early September, the brightness leapt beyond projections as though a switch had been flipped. The timing of the surge coincided with the object crossing within 2 astronomical units of the sun, a distance equal to roughly 300 million kilometers. For some, this seemed more than coincidence. It gave the impression of a trigger, as though the object responded in a specific way at a specific distance. Whether this is the result of an unusual composition or something more complex remains the subject of ongoing discussion. Unfortunately, one of the difficulties with 3I/Atlas is the challenge of observation. By late summer, professional telescopes such as Hubble and the James Webb Space Telescope were no longer able to capture clear images. The glare of the sun and the geometry of its orbit made direct tracking difficult. This left much of the responsibility to amateur astronomers with high-quality private equipment. These enthusiasts, many based in regions with clear skies such as Namibia, became crucial to monitoring the object. Their data filled in gaps and revealed new features, including a striking green glow. The green hue is not just cosmetic. It comes from a molecule called diatomic carbon, or C2. When solar radiation excites this molecule, it emits light in the green part of the spectrum. Many comets display this to some degree. But what stood out about 3I/Atlas was how quickly the green emission appeared, and how consistently it was maintained. Early data had not shown high levels of these molecules, which meant they were likely released only once the object came closer to the sun. While this can happen with ordinary comets, the timing and stability of the glow have led some researchers to suggest that the process might be unusually controlled, or at least not entirely chaotic. One of the most puzzling aspects, however, has been what astronomers call the anti-tail. Normally, comets develop tails that point away from the sun, shaped by the solar wind and radiation pressure. This is one of the most fundamental and predictable behaviors in celestial mechanics. Yet 3I/Atlas appeared to form a structured tail pointing towards the sun. Images showed a cigar-shaped extension oriented in the opposite direction of what physics would predict. For a natural object, there is no obvious mechanism to create such a formation. While there are possible explanations involving complex interactions of dust particles and viewing angles, the data has not yet offered a fully satisfying answer. Size estimates also add to the mystery. Analysis suggests that 3I/Atlas may be up to 46 kilometers in diameter. To put that into perspective, this would make it significantly larger than both Oumuamua and Comet Borisov, the two previous interstellar visitors we know of. A structure of that size maintaining stability over billions of years in interstellar space is not impossible, but it does raise questions. Natural objects tend to fragment, erode, or reshape under cosmic stress. For 3I/Atlas to arrive intact at such a scale makes it unusual compared with known comets and asteroids. Chemistry provides another layer of intrigue. Spectroscopic data indicates the presence of nickel but comparatively little iron. In natural spacewalks, these two elements are usually found together in predictable ratios, since both are formed in stellar environments. A mismatch in these proportions is highly unusual. While one cannot jump to conclusions, the ratio resembles that of refined alloys used in human industries. This does not prove anything beyond doubt, but it is a data point that does not sit comfortably within existing categories. Astronomers are well aware that anomalies do not necessarily imply anything extraordinary. Often, new discoveries force a re-evaluation of models rather than evidence of something artificial. Yet the collection of anomalies with 3I/Atlas has been enough to attract the attention of respected voices in astrophysics. Harvard's Avi Loeb, for instance, has become known for considering unconventional explanations for interstellar objects. He has pointed out that while none of the anomalies individually prove anything, together they create a profile that looks very different from known natural comets. Loeb has argued that if we were to design a reconnaissance probe from another civilization, some of these features, precise orbital alignment, unexpected chemistry, unusual tails, might be exactly what we would expect. The orbit itself adds to this line of questioning. 3I/Atlas is traveling on a path just 5 degrees off the ecliptic plane, which is the flat disk where the planets of our solar system orbit the sun. For an object arriving randomly from interstellar space, such alignment is statistically very unlikely. The chance of it matching the planetary plane so closely by coincidence is thought to be less than 1%. Moreover, the trajectory brings it near Mars in early October 2025, close enough for instruments on spacecraft orbiting the red planet to take observations. This has created an unprecedented opportunity for close-range study. If those instruments detect ordinary geological behavior, the case for a natural origin will be stronger. But if they detect geometric structures, unusual signals, or sustained anomalies, the discussion will move in a very different direction. Time, however, is not on the side of observers. By late October, 3I/Atlas will move into superior conjunction, where it passes behind the sun as seen from Earth. The glare will make observations nearly impossible until it emerges months later. This means the window for study is narrow, and astronomers are working against the clock to gather as much data as possible before the opportunity closes. At its closest approach to the sun on October 31st, it will experience intense heating. What happens then could provide the most decisive clues yet, but ironically, most of it will take place hidden from human instruments. The broader context of solar activity complicates matters further. We are currently in a period known as solar maximum, when the sun produces frequent flares and coronal mass ejections. These energetic events can affect the behavior of comets and other small bodies by disturbing electromagnetic conditions in the solar system. Determining whether observed anomalies in 3I/Atlas are a result of solar composition or simply the chaotic effects of solar wind is a major challenge for researchers. For now, 3I/Atlas remains a subject of intense interest not only scientific. Questions for listening.
The data is incomplete, the interpretations vary in states existence to the critical senses. Whether it turns out to be a natural oddity or something that forces us to rethink our senses, it is a reminder of how little we truly know about the objects drifting between the stars. The mystery of three last cycles is still unfolding, and in the months ahead it will, as it said, enter category of unusual comet or stand out as something apparently of unusual comet or stand out as something apparently without question.